Hello and good afternoon. Welcome to today's webinar from Safeguard Europe. Today's subject, waterproofing basements and underground structures. My name is Damien Wallace, Technical Manager here at Safeguard, and I'll be presenting today. It should take about 50 minutes to go through the presentation, and at the end of the talk we've allowed for about 10 minutes or so to answer any questions that might come in. Now there is also a link in the YouTube description where you can submit questions during the presentation. Also in the YouTube description is a link to register for CPD certificates if you require one. So today's subject, basements. Basements are enjoying a resurgence in popularity, but obviously it is crucial and crucially important that they are properly waterproofed. Today's seminar looks at the different waterproofing options available and assists the specifier in choosing the correct system for a given construction type and location. So with the next hour, you'll find out about guidance documents which are available to help with that, getting the design right to ensure compliancy and efficacy at the same time, types of waterproofing systems which will help to achieve this, and also more crucially is working with specialist waterproofing designers and contractors to ensure that the design is carried out to correct standards. So without further ado, we will begin today's presentation. So a quick bit about us as a company. Safeguard has a long established history of manufacturing damp proofing and timber preservation materials. We're also suppliers and distributors of structural waterproofing materials. We have a dedicated team of materials scientists or material chemists to help us to ensure that quality control is maintained, as well as sort of the development of new products within our range as well. In the kind of rather enormous world of remedial treatments, we like to kind of consider ourselves as market leaders. And in that work, we have a lot of research collaborations over the years, which have also provided us with third-party test data, which helps us to attain certifications such as British Board of Agreement certificates or BBA certificates in the UK and overseas equivalents where we distribute to over 18 different countries. Safeguard's product range spans many aspects of dampness in buildings, including materials for structural waterproofing solutions as well. So today's seminar, really what we'll be looking at today is kind of the main guidance documents which relate to structural waterproofing to ensure that your basement is both effective and compliant to regulations, and as well as the evolution, if you like, of basement waterproofing systems over the years, learning from mistakes, if you like, and how we've kind of perfected the system year on year. We'll be looking at advice on waterproofing design solutions, and of course, of great importance to specifiers is managing design liability, which involves working with specialist waterproofing designers and contractors alike. So, first off, we'll have a look at these relevant documents that we've been mentioning. First of all is BS 8102, which is a core guidance document for basement waterproofing within the UK. And anyone involved in any way with the design of basement waterproofing solutions should be familiar with its contents. First published back in 1990 and second edition in 2009, and due for renewal hopefully within the next year. We should be coming out with a third edition. But there are some kind of key points on there to bear in mind, including sort of waterproofing design types, head of water pressure, waterproofing performance, which we'll go into in a second. So while adherence to BS 8102 is not a legal requirement, there would be a risk of being considered negligent if a waterproofing system failed and the designers had not followed the guidance provided in BS 8102. So what is expected from basement waterproofing? Very simply, most people will do a dry basement, but how dry is dry and how dry do basements literally need to be? So really for most of the time, the starting point for kind of discussions is what is the area to be used for? So for example, if we look at this table here from BS 8102, we can say, for example, a basement car park situation, which would be environmental grade 1 in table 2 here. It describes some seepage and damp areas are tolerable depending on intended use. Local drainage might not be may be necessary to deal with seepage. So a certain amount of dampness would be expected. However, what we are probably most of the time looking forward towards designing would be a kind of a grade 3 environment. So that's where we go from grade 1, where some moisture is acceptable in terms of leakage. Grade 2, for example, plant rooms, workshops, where a drier environment than grade 1 is required. However, it's not habitable space. That's where water penetration is not acceptable, but there may be some kind of dampness, some humidity, some environmental humidity, which might need to be controlled as well, which is where we get to grade 3, where this is sort of the residential, habitable spaces, anywhere where you're going to be sort of spending more time in there, either kind of work or habitation. And this is where no water penetration is acceptable at all. And ventilation, dehumidification and air conditioning is necessary, appropriate to the intended use. And that is where the specification comes away from waterproofing into environmental control, appropriate to the intended use. So that really kind of gives us an idea about performance. In addition to that as well, on the right here we have a sample from Building Regs 2013 Part C, which refers to kind of the impact of moisture on structure, on sort of, and its effect on ground slabs and retaining walls, etc., and how the building should be protected from the effects of moisture as well. The UK approach to basement waterproofing seems to be very much about keep as much, it could be summarised, I should say, as keep as much water out of the basement as possible, and redirect any water that manages to seep in towards a sump and pump. So over the years, since the kind of the mid-90s, systems have kind of changed quite considerably over that time, and a lot of mistakes have been learned, and it's very much more now a belt and braces approach, and does involve some sort of advice learned off the back of a case called Outwing versus Weatherald, which back in '99, which kind of helped highlight the importance of having two systems as much as possible to prevent the impact of water entering a structure unwanted. So in contrast, many other countries will have a much more kind of robust approach in terms of the design of the building itself physically prevents all water from entering the structure. And usually avoiding the need for any kind of mechanical pump. But we are where we are in the UK with our market of kind of both refurbishment and new builds construction in differing materials. So we'll take a look at the kind of evolution of waterproofing in a bit more detail later in the presentation. So that's BS 8102 again, and it mentions, one of the things that it does mention is the water head, so the height of the water likely to bear against the structure. Now this can be determined in a number of ways, in terms of like costly site investigations, hydrogeological reports to establish where the water table may or may not be, how likely it is to be variable, whether it's a low or high risk situation. Very often this kind of advice can be superseded, as it is in NHBC chapter 5.4, which we'll look at in a bit more detail later on as well, which is to generally assume the full height of water during the design life of the building, which is to say kind of generally err on the side of caution and just design into a worst case scenario. So rather than kind of trying to mitigate how high you might take the level of your waterproofing on a structure, making sure that you design your waterproofing of the substructure and link it to the superstructure damp proofing course. Then that way you're kind of fully enveloping the structure and protecting it against any kind of water from the ground. Okay, so a little bit about waterproofing types as defined in BS 8102, which there are kind of three types, A, B and C. A being barrier protection, which can be applied to the inside, the negative pressure side if you like, or the outside, which is the positive pressure side of the structure, or even sandwiched in between. Sorry, I've got ahead of myself slightly there. So that's kind of the type A barrier protection. Type B is your kind of structural, your structural waterproofing systems, which is basically structural integral protection. So this is waterproof concrete designed to be waterproof. So actually the structure itself is doing the work. With type C systems, these are what we call cavity drain systems generically, and this is much more about kind of water management, where you're accepting that a certain amount of water will enter the structure, but you're managing when it does come in and redirecting it towards a sump chamber and a pump where it can be redirected further out to groundwater drain systems. So those are kind of the three main types of systems that we have there. So with type A systems, what we have again is a barrier protection system, and where there is a new build property, for example, a new build construction, there is an opportunity to put it on the outside of the structure in a positive pressure system. Internally, as it may often be used in refurbishment of basements, or indeed situations where the structure is built, for example, with piled walls, you may need to waterproof on the inside. Then obviously these type of systems can be used. And in the middle here is what's called a sandwich waterproofing system. It should be noted that this system in the middle is probably to be advised against. It doesn't lend itself for much in the way of repairs to that system, unless of course you add in an additional layer of a secondary system. So really anything which you can put on the positive pressure side, the benefit being that you can benefit from the pressure of the water pushing against the structure and keeping the system in place. On the internal waterproofing side, on the right hand side here, then obviously that may be a case where you have to install it out there out of necessity, but it can be mitigated with a secondary system as well. Okay, so a few examples of type A barrier systems. So cementitious slurries can be sprayed or brushed or even trowel occasionally. Bonded sheet membranes. We have sort of liquid apply systems which can be sprayed as well, PU systems and such, polyurea. We also have kind of the crystalline active slurries which can be sprayed onto concrete as well. Crystalline active slurries are slightly different from the standard sort of cementitious slurry which you might see as a traditional tanking. And they work in a slightly different way. So just to run through this kind of chart here, where we obviously have the structure is formed from new concrete. Crystalline actives can be applied internally or externally. The new concrete will contain a certain amount of free lime within the structure. And what happens is that these crystalline active slurries will react with the free lime within that structure and actually cause the growth of crystalline complexes which grow back into the capillary pores indicated in red. Just if I just put the pointer on here, just over here. So this is where the crystalline complexes are growing back into the structure, and they will help to kind of prohibit the moisture from penetrating through the structure any further. Often combined with type C systems, the cavity drainage systems, as they also kind of offer some protection against free lime by restricting the growth of free lime by actually kind of inverting it back into the concrete. So a very good system to use. Often benefits of this include things like coverage rates, because it is not applied as a thickness of layer. It is literally like a kind of a cementitious paint almost when it's applied. It can also be dry sprinkled onto wet concrete or damp concrete, green concrete, and be used, for example, on the top of a slab before the concrete wall is sat down and cast on top of it, and that will help to provide a construction joint protection layer between the two elements, the slab and the poured concrete wall. So quite a sort of diverse product. Where we are applying type A systems internally as a protection layer, we do need to be mindful of some conditions that must be met. And when you do apply these systems to the internal face of the basement wall, known as the kind of the negative side, there are additional demands placed on these type of systems. Any groundwater pressure can effectively push through and kind of effectively delaminate that tanking layer from the wall. If you consider, for example, old Victorian brickwork as a good example, obviously there can be conditions there where we have weak mortar, weak bricks. Water pressure that is strong enough can easily push through that kind of element of the structure and create a waterproof pressure behind the applied layer. So these systems must be capable of being applied to a damp substrate, which sounds pretty obvious. Most cementitious systems will easily do that. must be able to withstand water pressure on the negative side. So that is slightly a gamble in refurbishment situations, less so in, shall we say, more designed and constructed basements. And water pressure must be resisted by the bond between the tanking system itself and the substrate and the actual substrate itself. So the substrate itself does need to be suitably prepared so that it's able to accept the tanking system without any kind of loose material, friable surfaces, etc., from being pushed off by any acting water pressure against the structure. So if you do have any doubt about the suitability of a product, then do ask the manufacturer for kind of evidence of this and how effective it might be, or advice on another way around the design of it. But yeah, big thing, if you are going to go for any kind of type A system on an internal side, on the negative pressure side, then you should absolutely ensure correct surface preparation is essential, and that any kind of application is carried out meticulously to make sure that you have a good strong bond against the actions of any kind of water pressure coming to bear. With type B systems, the structural integral protection, effectively the structure is the waterproofing system. So this can be a combination of waterproof concrete designed to be waterproof or waterproof additives included. So in this aspect, what we have to consider as well is that the construction joints should be considered as potential weak spots for water to come in. So even if the structure itself was formed from stainless steel, those construction joints are where the problems will occur. So there are considerations to be borne there, and concrete should be designed to BS-EN 1992 Part 3. It will be waterproof and not vapour-proof, so an external or internal vapour-proof membrane may be required. There would be some consideration around the cost of possibly additional steel reinforcement to form a structure able to kind of withstand pressure. And with those day joints and those kind of construction joints, it is worth considering. For example, most basic design, we might form a raft slab and build a wall straight off of it. It might be worth considering putting in an additional kicker, as we show at the top here in this image, which will kind of take the level of the construction joint slightly higher above the point at which water is likely to collect on the top of the extended toe of that slab and creep through. This takes it at a slightly higher point, so it's less likely to build up and creep through that construction point, particularly when an additional water bar, a water stop or hydrophilic strip has been applied in that structure as well. So dealing with those construction points is absolutely key, even with waterproof concrete systems. So when it comes to kind of waterproof concrete, there's kind of two main forms really. It's kind of waterproof concrete with admixtures, where there is a kind of an expectation of a kind of a crack width should be limited to 0.3 for flexural cracks and 0.2 for cracks that pass through the section. There are conditions, and there are companies out there that will kind of monitor the mix, the additives going in, and the supervision of the mix, and the pour of the concrete on site, and sign off on those applications as part of a kind of a guarantee system. We are looking to apply concrete which is designed without admixtures, and it's actually kind of the strength of the concrete itself. Then there are other expectations as well. You should be looking to expect some post-construction crack inspection. It may be that you need to kind of resin eject afterwards to kind of deal with any kind of shrinkage or thermal cracking that might have happened as well. So there may be some sort of post-installation work that needs to be carried out. And a minimum section thickness of 250 mil should be used in this kind of design as well. So again, refer to BS-EN 1992, Part 3, Code of Practice for Design of Structures for Retaining Aqueous Liquids for further advice on that. Okay, cavity drainage systems, drainage protection, Type C, however you want to call it, egg box, bubble wrap, milk, all sorts of nicknames this stuff has. Often implied internally. Geotextile based versions, backed versions can be used externally as well to offer additional drainage layers on the outside of a structure. But effectively cuspated or dimpled plastic membranes now a very familiar concept in the UK, and certainly in terms of basement refurbishment projects, they are preferred by specialist contractors, mainly because they eliminate any kind of issues with bonding, delamination, adhesing. Much easier for surface preparation, much simpler to apply, less disruptive prep work. But they are kind of an alternative to type A and type B systems, whereby they actually control any kind of water which it's anticipated that some amount of water will come in, and they then control the flow of water to a point at which it is directed into a sunken sump chamber with a pump in there, which will then take it out to surface water discharge. So there is some requirement for the actual kind of structure itself to have some primary resistance as well, though. So it is worth inspecting the substrate to make sure there's no free water literally running in. Once that has been kind of, some localized repairs have been applied, then obviously you can apply these membranes and create a kind of fully draining system much easier without too much risk. So really, when it comes to this is just to kind of reiterate, and this is in BSA 102 and also further mentioned in Basement Information Centre Design Guide. The external basement wall must provide enough resistance to the water ingress to ensure the cavity accepts only a controlled amount of water or dampness. Is the kind of probably the short version of that. So some localised repairs may be needed to carry out to allow the system to manage the amount of water come in, rather than just constantly be running where free water is running into the structure. So just some examples of Type C system being installed to a city centre retail environment. This is where it was actually used as a refurbishment, where the primary system, the Type A system, had failed and allowed water to egress in. So the only option was to provide an internal system. So although it's relatively sort of newer structure, this is where the cavity drain system came to the rescue in terms of opting for an option to manage any water which was likely to come into the structure still. And again, Chelsea Academy, similar construction. This is obviously a new build structure, as you can see by the condition of the concrete here. And this is obviously installed as a secondary system, obviously a high prestigious place. It's also a sports hall. No option there for kind of any risk of water to come in, and if it did come in, then it could be easily managed by having a cavity drain system installed. And the cavity drain systems work are kind of enabled, should we say, by the inclusion of perimeter drainage. So this is kind of a proprietary channel installed at the wall floor junction preferably. There are different ways it can be set up, kind of preferably in the recess of a slab, so the lowest point takes it to the next lowest point, i.e. being the sump chamber, where it will be pumped out. So these would be installed, and additionally you want to kind of make sure that they are accessible, that there is access points installed around the perimeter of your structure, so that the channel can be flushed through. It could be rodded through if need be, that any kind of loose debris, free lime, silt, any kind of rubbish can be flushed through into the sump chamber and removed, so that you know that whatever's happening on top of that slab, that channel is being fully maintained, and water which does get under that system will always be able to move freely. NHBC chapter 5.4 has the following requirements for pump systems. There should be a primary pump system, mains operated, a secondary pump system, which can be operated by a battery or kind of a generator backup. There should be an audio visual alarm that indicates failure should that happen, and the pump should operate automatically. So most of these pump systems that you see in the market will have a float arm, which will kind of kick into action once the level of the pump, of the arm has reached a certain level. It will activate the pump and pop it into action. And additional to that, once those pumps have been overwhelmed, should that happen, then there are secondary miniature float switches which will then activate alarms as well to indicate that there is a failure to the system. In simple terms anyway, there are telemetric systems which will contact you by mobile, all sorts of systems out there as well. Okay, so our friends at the PCA, the Property Care Association, have a best practice guidance document as well for groundwater pumping stations for Type C systems, and in that, because very often we get asked, well, how many pumps do we need, what size chamber, etc., etc. The kind of the best practice guide as a kind of a coverall, if you put a gun to somebody's head, they would probably come back to you and say, one sump per 50 linear meters of channel. So that's one sump chamber, which would have 2 pumps in it. So a mains operated and a battery backup system would probably be preferable, linked up to an alarm as well. That would be a good sound solution. And as I say, yeah, 50 linear meters, so 50 meters of perimeter per sump chamber as an approximate guide. Obviously, what you can't account for is changes of conditions to structures in and around the basement that you're waterproofing, weather conditions, groundwater conditions. All sorts of things can change over the period of years and the life of the structure. So it's best to kind of opt for that worst case scenario and put in a system that's going to deal with as much as you can expect. Okay, one of the things to watch out for, we mentioned free line previously as well, is the build-up of free line, and this is why it's important to operate kind of maintenance schedules for pump systems, and to also install those access points within the perimeter channel as well to make sure that they can be properly maintained. The risk of free line, as you can see in these photos, can be quite damaging, and obviously once that pump's failed, then the water that's collecting there is not going anywhere. Before you know it, you're ankle deep in water. There are ways of kind of managing kind of the onset of free lime in terms of lime inhibitors on concrete prior to application, but also kind of lime destroys, like the acids, for example, which will kind of break down lime if used carefully, acid solutions, once it has become present. So normally you would expect to have a pump maintenance schedule for your basement waterproofing system to manage the effects of free lime. This is how it kind of sometimes looks more innocuously here. He says, looking at a photo of a rather damaged car at the bottom right there. So really what we're looking at is when you install these type C systems is that as part of any kind of any design system, you should include a pump maintenance program, which may be kind of every 3, 6, and then annual kind of inspections after the first year, where most of the free lime would have kind of washed through by then. And I would suggest that most people, specialist contractors that install these kind of systems, would suggest that if you do not combine by having a pump maintenance schedule and annual inspections, for example, then you would forfeit the terms of your guarantee as well. A very quick side note on the importance of UV protection. It has been noted over the years as part of the ongoing kind of evolution of these systems that clear membranes, non-pigmented membranes, tend to have a poor reaction to long exposure or prolonged exposure to sunlight. So UV light can tend to make them brittle. It's something to be aware of, but not to panic about, but kind of certainly worth considering where kind of materials might be stored on site for a long time. If that happens, just make sure they're covered up so that they don't succumb to this phenomena. When it comes to suitability of waterproofing systems and combinations of systems, we do have this rather kind of complicated chart available in BS 8102 in the current incarnation. Hopefully this might change in the new one. However, what we see in the red there is, and this is kind of about measuring the risk, if you like, of high to low water table, in terms of classifications. In red at the bottom, I think bypasses all of this. Is, as we should see, this table is somewhat outdated as combination systems are now used in almost all modern basements. So particularly with what we call grade 3 systems, where this is habitable space, you would pretty much always use a combination system in basement waterproofing design. And this is a reference to external basement drainage. So if you have the opportunity to kind of have a dig out, if you like, set your slab down and construct your external walls and waterproof from the outside, then there is an opportunity to provide some drainage. Whereas it says here, where practical, water should be kept from prolonged contact with perimeter structure walls or base slabs by porous or open jointed land drains, combined with the geotextile or geosynthetic drainage composite installed to full height of the overturning wall. So effectively you have a geotextile back cavity drainage system on the outside of the structure, which will help kind of direct water down away from the structure itself to a perimeter land drain, which should be in a bed of aggregate, and it should also be wrapped in a geotextile sheet as well, linked to the geotextile of the actual kind of membrane against the wall. As an indication, we quite often see this little thing happen where the land drain is sat atop the toe here. Best advice would be move it down at a 45-degree away from in line or below the level of the slab. If it's sat here, it will collect water against this potential construction joint between the slab and the retaining wall. And that's where you're asking for water to collect and just track through or put it under more pressure than it should come to bear. So to bring it away from the wall in positions 1 or 2 is much more acceptable. Okay, construction joints and service entries. When we consider things like NHBC Chapter 5.4, which we'll look in a sec, we are looking at things like minimising and avoiding any kind of penetrations through the structure itself. So do bear in mind when you're designing a structure and kind of where surfaces do need to come out through, rather than taking it through kind of a layer of waterproofing, actually try and design it up and over and out so that we are reducing the point at which kind of surfaces need to penetrate any waterproofing system, and that will help to kind of reduce the risk of subsequent failure. However, sometimes you can't avoid it. They are there. Certainly, certain construction joints between wall and slab, for example, are unavoidable. And there are kind of a number of ways, from kind of hydrophilic strips and water bars to kind of elasticized adhesives and construction joint tapes, which are kind of bedded in with polymer modified slurries, bedded in with construction joint tapes against those structure points. So on the positive pressure side, to stop water from penetrating through. However, occasionally you might run into a situation where you do have to go through. It could be a basement refurbishment, it could be an existing service which is immovable, and you have to detail around that. And this is where, as much as we can show all sorts of details, it is important to be using experienced contractors who will help to kind of use their kind of wherewithal and use of the right products to kind of deal with these kind of situations. We are also required to mention fire safety in basements, or at least kind of nod to it and give you kind of directions to go to. So approved documents B for volume 1 for dwellings and volume 2 for buildings other than dwellings. And it does in those documents lay out conditions and, for example, regards emergency escape windows, protected stairwells leading from the basement to a final exit. So there's a lot of conditions of the types of fire doors required, the consistency of access and egress in the sort of area that is below ground in a situation that there is a fire. Additionally, we are also required to kind of mention the effects of materials in situations where there might be a fire. So back in 2020, in January, for example, we have this document, a review on the ban of use of combustible materials in and on the external walls of buildings, including attachments. And this is obviously as a result of the Grenfell incident. And it does, although it's not specific to basements, it does give us a nod in the general direction of the consideration of any materials likely to be flammable in building makeup. So it may kind of give us a clue to how the future is going to go in terms of waterproofing. So we have to consider things like plastic membranes, polypropylene membranes, HDPE membranes. When burned, they do release things such as hydrocarbons, carbon monoxide, carbon dioxide, aldehydes. So there are effects when these materials do burn. And obviously with cementitious materials, with the right kind of substrates to be applied to, obviously they have a benefit of, so cementitious tanking, for example, might typically be rated as a Class A product in reaction to fire. So obviously there's a clear benefit in terms of fire resistance over cavity drainage systems, but really it's about a case of trying to sort of balance out what your obligations are now as about what they might be down the line in the near future. There are specialist membranes on the market. Certainly our supplier has specialist membranes which are used with a sort of a basalt fibre back to it, which are for kind of used in tunnels where obviously it has a great fire resistance to it. Can be cost prohibitive at the moment, but down the line we might see this becoming more of a norm and sort of these fire resistant membranes being used. So it's just kind of a nod to the future really. Okay, so improvements in basements and waterproofing standards from the 90s to present day. So where do we see basements fail? We've seen lots of things happen in terms of construction joints. We've seen things happen where there has been singly applied systems which have failed and allowed water in, and this has resulted in new case law, which has set a precedent for applying combination systems. So systems which are a primary followed by a secondary drainage system usually. So often where the problems occur, as you can see in some of these phases, is where the construction joints have failed. So the new case law that we referred to, this was the case, Outling versus Thomas Wetherald, High Court ruling over basement waterproofing failure at a nursing home in Croydon. A primary system shown here in the line in red was applied, but just that, nothing else to it. In addition to that, you can see the water in this diagram, the landrome is situated in a rather high position as well, so not really helping take water away from the structure by being below or in line with the slab, but rather high up above the actual construction joint. In addition, it became damaged in site conditions by all accounts. Anyway, it went to court, and there was a ruling found at the end of it that basically the precedent is that it's not reasonable to expect an externally applied waterproofing system to be applied perfectly, and a margin for error should be included as part of the design. So a form and feasibility of remedial work should be considered. So multiple waterproofing systems, again, depending on the grade 1, 2 or 3, should be considered to provide a good waterproofing system which fulfills the terms of the contract, i.e. a waterproof basement. So obviously with BS 8102, the lessons from Outwing were reflected in 2009 edition. So where defects may occur, systems should be repairable, and combination systems should be considered if you want to kind of further your offer of protection on a substrate. In addition, I mentioned this a couple of times through the presentation so far, NHBC, National House, they had a campaign started in 2013, and they had run a kind of a review between 2005 to 2013, claims relating to waterproofing of below ground cost NHBC in the region of £21 million and affected 890 homes, so about 23.5 grand per house. Over that period, and that gave them cause to review the claims that were made and take a much more analytical approach to structural waterproofing in terms of their future warranties and guarantees. So they stipulated they found a few weak spots, if you like, in design where things were going wrong, and they wanted to kind of alleviate those problems, so reduce their payouts effectively, but also ensure any inconvenience to homeowners wasn't an issue anymore as well. So some of the issues were kind of jointing defects at ground level, where substructure meets the superstructure. So not just at the wall floor junction, but at the top where the basement stops and the ground walls start to build up on top of it. Service penetrations, podium slabs offered about 12% of claims. A single system being used alone, so either Type A or Type B waterproof concrete, but without any secondary system in projects with a high or unknown water table. And often, as sad as it is, poor design and workmanship. That was about it. It wasn't thought of properly and it wasn't installed very well. And I think that's where a lot of the issues occurred as well. So NHBC took the findings from the basement study and codified them into new guidance. So in once these were kind of released, it's built on top of the advice given in BS 8102. Again, not mandatory, but still very good advice. And if you combine this with BS 8102 and look at the advice given in those two documents, then you're going to have a very successful kind of design and basement construction. And it has proven also to be a success, and as of 2019, NHBC had not had any basement waterproofing claims since the Chapter 5.4 was introduced back in 2015, so a worthy document indeed. Okay, so some of the things that the document lays out are including a qualified CSSW system designer, certified surveyor for structural waterproofing, combined systems to make sure that you are kind of accounting for any potential damage, failure in the original waterproof system. Assume a full height of the basement for waterhead. Trained applicators. So people who are kind of installers that have been trained to use this product correctly. Simplicity of design. Make sure that the structure itself doesn't offer too many complications that are allowed you in hot water early stages. Make sure the substructure, superstructure detailing is linked. Making sure that you have an appropriate pumping system, a pumping station for your Type C system as well. So this is what we're looking at: Type A's and B's and C's. So effectively, barrier systems, waterproof concrete systems, but all, should we say, supported by the inclusion of a cavity drainage system to collect any water which might come through construction joints and the such. So modern basement systems, this is where we're going to, just a reminder of what we mentioned before, with the general premise trying to be keep as much water out of the basement as possible and redirect any water towards a sump and pump to remove the water. And this is kind of what we're looking at. These are kind of systems that we've kind of come across that we subject of basement types, common scenarios. So new build reinforced concrete, where we have an opportunity to use things like crystalline active slurries between construction joints on the external face of the structure as well, possibly waterproof concrete indeed, a water bar between the construction joints to enhance the waterproofing, even a strip on the outside as well, a construction joint tape on the outside to additionally enhance that, a drainage layer on the outside as well. And I mean, this is all bells and whistles one, and even a drainage layer on the inside, which will collect any water which God knows how to get through that lot, but if it did, it would initially be collected and taken to a sump and pump system. So a complete and utter bells and whistles on this one for high risk situations, but some of those parts might be interchangeable. Okay, system 2 is kind of your dig out or your underpinning of existing dwelling. So this is where we occasionally see these systems where the excuse me, where a basement is effectively being lowered to become kind of deeper than it originally was. So in these kind of situations, we have things considered such as dry pack, kind of a loose material between the concrete and the original and existing brick structure. So we've got a different amount of materials. So this joint here is something to be careful of. So we can provide some type A systems on the structure to offer some solution, but it's going to be limited in success because of the different materials. So the cavity drain system is your kind of capturing system, if you like. So anything that does get through those risky points, it will be collected and managed by the cavity drainage system. Just an example is kind of underpinning where you can see dry pack and sort of loose material in between the concrete and the original structure. Okay, piled retaining walls, and we see this a lot in urban areas where we are perhaps building in between existing buildings. So we don't have a big hole in the ground in the middle of the field that we can excavate and then build from the bottom upwards. This is very much about top-down construction. So the piles are drilled down and filled with concrete to form our retaining walls. And then obviously as we excavate down to the level where the slab is then installed against, perpendicular to the piled walls, now we can kind of reinforce the concrete piles with either cast concrete, formed concrete, or even sprayed concrete against these walls. So here is the joint that we need to manage. So again, we can add on a type A system as our primary system to the wall and the slab and the junction between the two. But we do need to be mindful of the fact that there's a risk for water still to come in. So again, providing an internal cavity drainage system against this perimeter channel will offer us best protection in this kind of scenario. And as we can see, we've got formwork set up against this wall and sprayed concrete and waterproofing additives being sprayed on top of that on these walls on the right here. And finally, system 4, which is kind of the refurbishment of an existing basement. So this is your combination system is not always possible in these kind of applications, although you might be able to provide a type A system of crystalline onto a new concrete slab, for example, if the basement floor is effectively just a bit of screed on dirt, or sometimes not even that, it's just bricks on dirt, then obviously a new slab, you've got the option to provide an additional waterproofing layer and lime control agent on top of that slab before installing your cavity drain system, which would be by far and away the best system to use in a situation where you have existing masonry and mortar courses, which is sort of unknown strength. There's a risk against that of putting a type A system. So this would give us a much more kind of risk-free solution. Just by example, you could be spending forever and a day prepping these surfaces before you can even put a type A system onto those substrates. With the cavity drainage systems, the process is much cleaner and quicker, less preparation required. What I might say is that there's some loose material to be removed, absolutely. Location of surfaces, water pipes should be considered, of course. Maybe some biocidal treatments, get rid of some of the effects of the dampness and the mould and the algae that's growing around here. Maybe look at any kind of embedded timbers which have to remain in situ, making sure that they are treated as well with a suitable biocide to prevent the effects of rot occurring behind the membrane as well. So do bear that in mind as an additional one. So when it comes to the basement waterproof, so those are kind of the four main types of basement scenarios. So when it comes to kind of basement waterproof design processes, this is a kind of little outline, if you like, of taking the basement design process from, should we say, the idea of a basement build, from construction process and choices through the waterproofing systems which might be available, into effective design, installation, and finally an established maintenance program, which should also be as part of a guarantee period as well. So we can see how we go from the idea of, well, we want a basement, how do we work it, what sort of choices do we make regarding the structure itself, how to simplify the actual design itself. An architect, for example, or specifier might contact us to sort of choose a system which is appropriate to that. And this is where, as suppliers, we're obviously limited in our ability to provide assistance, but we do what we can to the extent of our remit. And then as soon as possible, really what we'd like to do is be getting you in contact with a waterproofing design specialist, as in a design consultant, should the job call for it, or a specialist waterproofing contractor. Now, either of these can help. They can work in conjunction, or you could just go straight through to point 4 and go for a waterproofing contractor who will install and ensure their own design as well as installation as well. And finally, we get to the stage where the job is complete, and now we're looking at making sure that we have the system has been installed properly, all terms of the guarantee have been accounted for. Now we just need to worry about ongoing maintenance and any kind of handover to the owner of the property. Okay, so when it comes to things like designing, step 1, designing resilient structure. This is where, if we dig down into that a little bit, a good 3-dimensional review of the structure and waterproofing should be undertaken so as to identify any complex geometries which are not readily identified from normal 2-dimensional details. And this is something BS 8102 reiterate. It's just making sure that there's a, buildability in your waterproofing system to make sure that it will fit the structure without any kind of too many hiccups involved, and keeping the process of the structure itself being stable, durable, anticipating movement where it might be, minimising surface penetrations through the structure itself. When we get to stage 2, this is about choosing the relevant waterproofing system or combinations of systems appropriate to the type of structure that you have. A waterproofing design specialist should always be included as part of the design team, as stipulated in BS 8102, and as it says in the HBC chapter 5.4, waterproofing systems should be designed by a waterproofing specialist. And this is where the line of inquiry can split between either using a design consultant or a specialist contractor to design and install as well. As we can see in this diagram, an outline design might come to us. We would work on them and say, well, we have this system, that system that could work in this, type A, type B, type C systems which could work. And usually that's where the inquiry would then move on to a kind of a CSSW contractor who would look at it and offer a design. And without necessarily a charge, assuming that it then is taken on to the installation process as well. An independent consultant will offer a percentage fee of the waterproofing contract value and offer the design, but the design only. And that's where, for example, with the independent consultant, then there might be an obligation for any installing contractors to carry out some product training to make sure they're familiar with the products that they're installing. Or in the case of going to a specialist contractor, they would offer the design and carry out the installation themselves. And then that's where the kind of the guarantees will then split up between design or design and installation. and that's where we get to in this stage 4, using a specialist contractor. The good thing about using a specialist contractor, so they could understand the correct sequencing of works. A lot of them will be able to carry out risk assessments for their own guys carried out on site. They'll be able to provide cost assessments for relevant products. They will be able to liaise with main contractor and following trades so that they can work with other trades prior and following to make sure that if the work needs to be carried out in sequence is carried out in the right order, with an understanding of surface preparation, detailing of joints, etc. And ultimately they'll be able to flex on site as well, so if changes in conditions occur on site, they'll be able to manage that as well. Okay, and finally we get to stage 5, which is handover and maintenance, and this is where the advice here is quite good, and obviously many people these days tend to be much more conscious of the work they're carrying out and like to log the application of the work that they do and keep a record of the work that they carry out. And this is particularly important when it comes to things like structural waterproofing systems, where you need to maintain a working system, but you might want to kind of prove it's been installed correctly through the entire process. There's a checklist that we can kind of advise people on with regards to things like flood testing the level of the slab, making sure that water is running in the right direction, checking out the condition of the substrate it's been applied to, making sure that any electrical work has been carried out by a qualified installer, making sure that the system is even tested on the floor before floor membranes go down and wall finishes are included. So just making sure that the process is run in a systematic way, which ensures that it's fully functioning. And at the end of it, there is advice handed over to any user regarding, for example, regarding activation of the alarm, any kind of subsequent works which might be needed to carry out, how it could be installed to not damage the waterproofing system that's been applied as well. And finally, a kind of a nod to basement ventilation. Obviously, you mentioned this before. Remind you, back in environmental grade 3, ventilated residential commercial use areas, including offices, restaurants, ventilation, dehumidification, and air conditioning necessary, appropriate to the intended use. So this is where we get to grade 3. So often in a basement refurbishment, it might be a case of just putting a fan in a corner, and that will kind of deal with a single space without too much problem. On larger projects, again, depending on it, if we consider a small workshop versus, for example, the restaurant of a kitchen, the kitchen of a restaurant above being down in the basement, there might be a requirement for some more substantial ventilation system to be installed, which is where someone like a HVAC contractor can be called in, heating, ventilation, air conditioning contractor can be called in to specify a specific bespoke system for the intended use. We should also know as well the PCA guidance documents advise on ventilation for basements in relation to things like approved document F as well in regards to kind of ventilation in buildings as well. So there's a lot of documental guidance out there for advice on kind of achieving the right systems conditions below ground. Okay, and of course, as a lot of kind of construction-related subjects, there is a clear kind of want, need, and will to minimise environmental impact as well. Royal Borough of Kensington and Chelsea carried out a study, and they showed that the embodied carbon in materials used for basement extensions considerably higher than above ground extensions. And so there are some sort of unavoidable conditions that can happen when kind of building below ground. So there are ways to try and mitigate that as much as possible. For example, a 20% reduction potentially in carbon could be achieved by using recycled coarse aggregate and concrete. And also your choice of waterproof materials could also affect your impact on the environment. For example, reducing the plastic used in some of these studded membranes. Some material suppliers offer things like recycling, returning remnants and offcuts for them to recycle. Some manufacturers offer that as an option as well. Some other systems are, these particular membranes have been designed for some time now with what's called multi-layer technology, which is 2 virgin layers of polypropylene with a recycled content in the center. And as a step further, they've tried to kind of take up plastic that has been used, harvested from the oceans, kind of used in fishing situations, of kind of the nets, for example, and kind of repurposing these plastics as part of a kind of a recycled element of the drainage layer to help kind of minimise embodied carbon and certainly the manufacturers that we use hydroelectric power, being based in Norway. They have a lot of hydroelectric power over there, and they're obviously very keen, one of the cleaner nations in the world in terms of recycling and green credentials. They have been producing multi-layer technology membranes for some time now. Okay, so in summary, we are looking at kind of just the kind of as a review. A simple design, reinforced structure with minimal surface entries and construction joints, use of combination systems to reduce risk of failure, using accredited waterproof materials where it's possible, so BBA certificates, CE certificates on all products, engaging with a basement design specialist, whether that's an independent or as part of a specialist contractor firm as well, used to install waterproofing system properly. And finally, ensuring that the handover documents and ongoing maintenance schedule is in position so that you can kind of secure that insurance-backed guarantee, which is normally run for a period of about 10 years from your specialist contractor. We have kind of finally run to the end of the presentation, so thank you for your time. So we've not had any kind of questions drop in at the moment, so that's not necessarily a bad thing. I hope you found the webinar helpful today anyway. So if you do have any questions subsequent to this, feel free to submit them in the link in the YouTube description page. And don't forget, you can of course use the link in the description to register for a CPD certificate as required as well. And lastly, Merry Christmas to you all, and we'll hope you join us in the new year with our first webinar of 2021, which is the 5th of January, which is dealing with dampness in existing buildings. So thank you very much. I hope you have a lovely Christmas and see you in 2021.